My name is Muhammad Afiq, and my partner is Paul Shamil, and I am from Group 6. So today I'm going to explain you about the LED event number. So without further ado, I would like to introduce the coding of the LED blinking in even number. So what we have to know is, firstly we have to put module and then declare the input and also output. So at the module we have to put our input or output, and besides the module we have to put our name of the file. For example, this one is shift4, and then in the bracket we have to put our input and also output, the combination of input and output. So after that we have to declare the input and also output. So the input is a clock and output is LED. So in this case we use green, a green LED. So firstly we write a coding for a clock. A clock is from, we have to change from 50 megahertz to 1 hertz, so that the LED can blink
in 1 second.
Yeah, this and when it changes to 1 hertz, it blink to 1 second.
Yes.
Yeah. And then we declare the counter is equal to 0, CL out, clock out is equal to 0, and then in, and so then we write always at post H clock begins if else statement, and then so we go to the end of the declaration of clock only. So guys, we proceed to Shamil.
Okay, my name is Muhammad Syamil Badr Majid. My metric number is 185162. Okay, our project today is about even number. So how we make? We make a shift register, which is PISO, which is parallel in, serial out. So first we go to the sub of our coding, which is mark DFF. So this is one module, which is module and M module. So this coding is about shift register, which is if select is equal to 0, the output will become D node. So if the select will become 1, the output will become D1. So this is the function, the sub function, that the sub module that we made in the coding. So we go up, and then this marks DFF stage 4 until stage 0 is a call function. We have a call function, and call function is divided by 2, which is called by reference and called by value. This is called by value, which is W we transfer to the D node, R4 we transfer to the D1, select is become L, clock will become clock out, and Q4 will become Q. Okay, what's it? Okay, clock is 1 hertz. We use 50 megahertz because 50 megahertz is already provided in Altera board. So we use a frequency divider to become 1 hertz. So for how it work, first when select is equal to 0, Q output become D node, which is this. So when L is become 0, the output will become W, Q4, Q3, Q2 and Q1. So if L is equal 1, the value will become R4, R3, R2, R1, R0. So in this hardware, D node until D4 we set as switch 0, switch 2, switch 4, switch 6 and switch 8. And L is switch 9 and W is switch 1. So this PISO, right? So if we set we can set the value of this. So in this we set value of this become 0. So if W we set to 1 and L, if we select 0, we set the value of W. So we set L become W 0. LED will out at the even number because we set the LED at the even LED pin. So if we put L equal to 1, if we push all of this to become 0, its function is like a reset because we set all the value of D is equal to 0. We also can set the value of D, it become 1 1 1 1 1. So if we set L equal to 0, it also fold the value of W, which is switch 1, but switch 1 is 1, so it become 1 1 1 1 1. So if we set switch 1 become 0, all will become 0. So how our coding is work. Okay, thank you.
That's all from us. Thank you.
Alright.